You type a name. A machine somewhere only understands numbers. And in the gap between those two things, the entire internet quietly happens. Computers don't speak in words like example.com. They speak in IP addresses, strings of numbers that route traffic across the planet. DNS is the translation layer that turns a name humans remember into a number machines can find billions of times every single day. But that phone book isn't one file somewhere. It's a distributed system of records scattered across thousands of servers, and today we're cracking open the four that matter most. Think of a DNS record as a single instruction line in a giant lookup table called a zone file. Each record has a name, a type, and a value. The type is the magic word. It tells the resolver exactly what kind of answer you're asking for. Let's start with the most fundamental one. Get this wrong, and your website simply doesn't exist to the world. The A record is the workhorse. It maps a hostname directly to an IPv4 address, like pointing example.com to 93184.216.34. When your browser asks where a site lives, the A record hands back the exact numeric address of the server. Its cousin, the quad A record, does the same job for newer IPv6 addresses. So a name becomes a number, and the packet flies off to a physical machine humming in a data center somewhere on Earth. But here's the problem a records can't solve elegantly. Imagine you own dozens of subdomains. Shop, blog, mail, all pointing to the same place. Hard-coding one IP address into every single record means that when the server moves, you must update every single line by hand. There's a smarter way. Instead of pointing to a number, you point to another name and let it inherit the answer. That's the name, short for canonical name. It's an alias that points one name to another name instead of an IP. So www.example.com can simply say, I'm the same as example.com. Update the target once and every alias follows automatically. This is exactly how services like GitHub Pages point your custom domain at their servers. But names come with a strict rule that trips up almost everyone the first time they try it. You can't place a name on the root of your domain, the bare example.com, because a name can't coexist with other essential records living there. That's why the naked domain almost always needs an A record instead. Break this rule, and your email and other services can silently stop working. Now for the record that decides whether your emails land in an inbox or vanish into the void completely. The MX record, Mail Exchange, tells the world which servers accept email for your domain. Notice it points to a host name, never a raw IP address. Each MX entry also carries a priority number, and the lower number wins, receiving mail first. It's how one domain can juggle multiple mail servers gracefully. So when someone hits send, their mail server quietly asks your domain, who's in charge of receiving this? Here's the classic disaster. People set up email with a provider like Google Workspace but forget to add the MX records, or leave an old one pointing nowhere. The result? Messages bounce, and no error tells the sender that your business just missed a customer. It's one of the most common self-inflicted outages online. But the wildest part is coming because there's a record that isn't really an address at all. It's a message board. The TXT record was originally just free-form text attached to a domain. But engineers realized they had a public, verifiable place to leave signed notes, so they invented entire security systems on top of it. Today, TXT records quietly power the trust behind nearly every email you send. Take SPF. It's just a line of text, but it decides whether the world believes an email really came from you. An SPF record is a TXT entry listing exactly which servers are allowed to send mail for your domain. When a message arrives, the receiver checks the sender against that list. If a stranger's server isn't authorized, the email gets flagged or thrown straight into spam. It's a public bouncer for your outbound mail. Then DKIM goes further, stamping every message with a cryptographic signature that can't be forged. DKIM publishes a public key in a TXT record. Your mail server signs each message with a matching private key, and the receiver uses that public key to verify nothing was tampered with in transit. Together with SPF, these records form the modern defense against spoofing and phishing attacks. There's even a clever trick where TXT records prove you own a domain before a service will let you touch it. Countless platforms verify ownership by asking you to add a unique random TXT string to your domain. Only the real owner can edit DNS, so publishing that exact value proves control. It's how you unlock Google Search Console, SSL certificates, and dozens of cloud services without a password. So now picture all four working together the instant you press enter on a web address. The A record finds the server, the name keeps your aliases tidy, the MX record routes your mail, and the TXT record proves everything is legit. Miss one, and something breaks in a way that's frustratingly invisible. Master them and you control how the internet sees your name. One more thing nobody tells you. Changes don't apply instantly. There's a timer baked into every record. That timer is called TTL time to live. It tells resolvers how many seconds to cache an answer before checking again. A high TTL is fast but slow to update. A low TTL updates quickly but hammers the servers. Lower it before big migrations, and your changes propagate in minutes instead of days. So next time a site loads or an email lands, remember, for quiet records made that happen. Learn them once and you'll never fear the DNS panel again.